Hello there. Oh, does it work? Yeah, can you hear me? Love it. Hey guys, so let me welcome you to the first talk of today on the stage, and our first speaker is Michalis. And I'm really happy that I can introduce him because we are friends. We were on crypto camp parallel in police together, and Michalis is a really cool guy. He loves privacy. He's a software engineer in cypherpunk, like many of you, I guess. So today he will tell you something about GRIN, and yeah, GRIN and privacy sounds cool, but I'm not really into Mimble Wimble stuff, protocols. So I hope you will
You
convince
may
me that
get
I'm
it.
wrong.
Yeah.
Okay, so let me hand over to Michalis and have fun.
Yeah. Thank you, Mario. Thanks everyone for joining this talk. I'm really glad that I'm doing this specific talk in this room because 2 years ago in Hackers Congress 2017, I first learned about GRIN in this very room. There was a talk about privacy-oriented cryptocurrencies, and GRIN was briefly mentioned. And there were 2 points that stood out for me. There was one that the founder is anonymous, and the second one it's written in Rust. So me as a techie and also someone who believes in that privacy is a human right, I was immediately hooked. Um, so I started researching about GRIN, and ever since, for the past 2 years, I've been following GRIN. I haven't done any development because I haven't had any time to learn Rust properly. It's kind of hard language to get it. But I've been contributing in other ways. I've been writing docs. I've been helping people set up their nodes or their wallets in the forums or in the chat rooms. I've been doing stuff like, also talking about GRIN with friends and onboarding them. And also, I've also donated to GRIN. GRIN is solely founded by donations. So this talk, really, it's just a walkthrough of the project. I want every one of you to, when you walk out of this room, to have an idea about GRIN. And actually, first a show of hands, who of you have heard GRIN before? Raise your hands. Okay, like half of the room, cool. So yeah, this is a walkthrough of the project. It's a pretty technical, I mean, it's technical. It has also some socioeconomical part, but I think the technical stuff are pretty easy to get to it. So I hope it's not gonna be difficult. And yeah, it's a bit opinionated here and there, particularly the socioeconomical stuff in the end is it's just my views. Yeah. Another question that I have for you is who has a technical background? Please raise your hands. So yeah, half of the room as well. Cool. So my background is I finished my bachelor's degree in computer science back in 2014. And ever since I've done some work on Bitcoin, on BTC Suite. Anyone familiar with BTC Suite? No one? So, one, okay, cool. Yeah, the Gold project. Yeah, I did some work there back in 2014 as part of an internship. Then I did some stuff on Kubernetes unrelated to crypto. This year I've been working in guard time. We are doing blockchain related stuff with healthcare. I can talk about this in private, but now I'm here to talk about GRIN. So in parallel, I'm doing also a master's in digital currency at the University of Nicosia in Cyprus. And I've been following GRIN for the last 2 years. And the TLDR about GRIN, or what I think is a TLDR, is that it's a cryptocurrency focused on privacy, scalability, and fairness. And the rest of this talk is really breaking those terms down. We are trying to explore really those what I think are the core tenets of the GRIN and its community. So how does GRIN how does it fare with privacy? And really, when we talk about privacy on blockchains, there are really two different dimensions. There is on-chain privacy and there is off-chain privacy. First, about on-chain privacy, there are really two big features that we have here. Actually, there are three, but the first two is confidential transactions and bulletproofs, which is what GRIN uses to hide the transactions on-chain. I'm going to briefly describe how confidential transaction works. There is a little bit of math there, so sorry about that. And yeah, there are no addresses also in GRIN. The way that transactions are built is interactive. And we can also discuss about how this works. There's a slide about it. So no amounts. We use GRIN uses confidential transactions. Anyone familiar with confidential transactions? A couple of people, cool. So they are based on elliptic curve math, and we're going to see how they work. Just a brief preview. And there's also bulletproofs. Bulletproofs are used for for proving that the amount that is hidden in the chain is within a specific range. And the range we are interested in is only positive values. We don't want people to be able to create negative amounts in the chain and hide them, because then they can inflate the chain and they can create money out of thin air. So the way confidential transactions work is, on the left you have a standard Bitcoin transaction where all the inputs and the outputs are obvious. They are you can see them in the chain, and you can verify that the transaction is valid. One of the things that you want to verify for a transaction is that it balances out, so there are no new money created. So you have inputs equal to the outputs. So the way it's done in confidential transactions is there is elliptic curve math that are used under the hood. So really the math operations here, the addition and the multiplication are elliptic curve operations. They're not integer operations. They're not the regular operations that you are familiar with. So really the way it works is you have your inputs and your outputs, and you use this H, which is basically a generator point in elliptic curves. It's a point that can create all of the other points in the elliptic curve. And that's the way you hide the amount. Is anyone familiar with the problem that is in this specific equation? You're familiar with it? You know? No, discrete log, I mean, it's problem in most of the crypto, but the specific problem here is that this can be brute forced. So as an observer in the blockchain, you can see this transaction on the right part. You don't know what are the amounts that are hidden, but you know H. H is a public parameter. So you can try it and use all of the values so that you know of, and you can brute force the transaction. So the way really that confidential transactions work is, so the V outputs are finite, so they can be brute forced. So the way that the really confidential transactions work is we need one more parameter, one more actually point in the curve. And this R is basically, it's called the blinding factor. And G is another public parameter generator and point in the curve. So this R basically is what is used to blind the amounts, and they can be brute force really. And this R is also, in the case of GRIN, it's also useful for proving the ownership of the output. If you know R, you can use the output. No addresses. So in GRIN, it's kind of weird for people coming from Bitcoin and other cryptocurrencies that there are no addresses in GRIN and Mimblewimble. And the way it works is that there has to be some interaction between the sender and the receiver before the transaction is sent in the chain. That interaction it has to happen online, but both parties, they don't need to be online at the same time. There are different ways where both parties can create the transaction. And basically there is three rounds going on. First one is the initialization step, where the sender sends to the receiver. It can also work on the other way around. Then there's a signing. The recipient signs the transaction. It creates some signatures, basically, for the kernels that I'm going to mention later. And then the third round, whoever has the amount, the output, it adds the last signatures and sends the output in the chain in the nodes to broadcast across the network. Off-chain privacy, how it works is there is transaction aggregation by default, so coin join. So you don't really need to do anything. You don't need to use any service to do coin join. It's done by default by the network. There is a Dandelion++, which is an open proposal for Bitcoin. And there's some discussion for using as one of the overlay networks, either I2P or Tor, for both for the peer-to-peer protocol and for building transactions in the wallets. So how transaction aggregation works is you have two transactions here with the inputs. So it's badly indented here, but on the left you have your inputs, on the right you have your outputs, and also the kernels. The kernels are what the things that hold signatures for the transactions. But this is it's really one of the One of the parameters that we saw earlier in the Pedersen commitment is what is signed and it's kept in the kernel. So you have your inputs, you have your outputs, and if this blue output in one transaction and the other, it's used as an input in the second transaction. So first we can aggregate the transaction and it's still valid. So from a network, from a peer perspective, when you see this transaction with two aggregate transactions, you just see one transaction. You can validate that it's one, but it's really two transactions. And also there is pruning going on, so we can remove these outputs. Yeah. Then the Lion++, there was actually a proposal by Fanti and others back in 2017, the first iteration of Dandelion. Then there was a second iteration on last year called Dandelion++. And really it's a way of propagating transactions in the network and trying to avoid the anonymization attacks where you have multiple nodes in the network and they listen on transactions and they can easily find the source of where the transaction was transmitted. And then the Lion helps with hiding the origin of the transaction. And yeah, in GRIN, it's also an opportunity to aggregate transactions when transactions are propagated as part of, there are two phases really in Dandelion. I'm gonna go through them, I think, now. Yeah, okay. So the way that transaction propagation works in Bitcoin, and it used to work also in GRIN, is you have mere diffusion. So a node, when it accepts it, or when it gets a transaction, it just sends it to all of its peers. So you get a transaction as a node, and you send it to all of the peers, and all of the other peers send it to their own peers. So that's how Bitcoin now works. With Dandelion, we have the concept of an epoch, and the epoch is really, at the moment, it's just 10 minutes, but it's configurable. And it's basically every epoch, a node decides to either be a stem or a fluff node. When you are a stem node, you basically you choose an outbound peer. It's really important that the peer is outbound because you will, as a peer, you have chosen that peer to connect to. And you send transactions just in that peer for that epoch. Whereas if you are a fluff node, you are a normal node who propagates transactions to all of the network, to all of your peers. And when you make a choice whether you are fluff or a node or a stem node, it's like 90% chance that you are going to stem the transaction, 10% chance that you're going to fluff. This is also configurable at the moment. So the way it works, let's illustrate it, is a node gets a transaction, it's a stem node, so it's just going to send it to one of its outbound peers. This is also a stem node, same thing, stem node, and eventually we get it to the fluff node who just diffuses the transaction. So it's a bit harder to figure out the origin of the transaction in this case. And yeah, it's obviously it has gotten its name from the flower dandelion, this protocol. There is also discussions on using either I2P or Tor for both the peer-to-peer propagation of transactions and also for building transactions, because the transaction building is a different step, as we saw earlier. Yeah, there are a couple of, there's an OpenRFC for Tor online transacting, and there's also a work in progress pull request for I2P. I'm not sure what's with what protocol we are going to end up. There are some still ongoing discussions in the community. So how GRIN fares in privacy? It's not a 100% zero knowledge like Zcash, for example, is. It's more akin to Monero. Transactional linkability is still an issue. You can still figure out when you send transaction in the network that these are its inputs and these are its outputs. And there's a work in progress to fix this. Still not sure how, but yeah. There are one thing that I really like about GRIN is that and it's also something that its founder embodied in its philosophy. The project's philosophy is that it's a minimalistic project, and it tries to keep all of the math to a bare minimum, so they are easy to maintain and understand. So there's no trusted setup, no moon math. And really, it's similar to, as I said earlier, to Monero. It's based on your network size, like any other decoy system, really. So how does it fare with scalability? There is transaction pruning, and because of transaction pruning, there you have a fast initial block download, and you also have a lighter chain. So you remember earlier how I showed you how transactions are aggregated. We can do the same thing with blocks. So blocks can be aggregated, and all of the spent outputs can be removed from the chain. So you really are left with your unspent outputs. And of course, the kernels are still the elephant in the room, as we're going to see. So to put things in perspective, Bitcoin today has around north of 200 gigs blockchain size minus the headers and the unspent outputs. And its unspent output size is only 3.4 gigabytes. So in GRIN, the unspent outputs are just a few, but we have still an issue with kernels. You need to keep around kernels to verify that all the transactions that happened in the network were valid. The issue with that is, I think, it's because of snort signatures. GRIN is using snort signatures, and snort signatures cannot be aggregated non-interactively. So really only when you are interacting with someone and you build a transaction, only then you can aggregate those signatures. I think there is some discussion on BLS signatures. BLS signatures would solve this issue if GRIN is able to use BLS signatures ever. We don't know yet. So you are left with your block headers, your unspent transaction output, and your kernels for an initial block download. So it's relatively fast, faster than Bitcoin. So yeah, it's really not an order of magnitude better than Bitcoin. It's a bit better than Bitcoin. We still need a second layer, of course, to scale. As we know today, with blockchains, you cannot really scale to Visa level transactions. It's mostly for security. And yeah, pruning helps, but we still have to deal with the kernels at the moment. And fairness, I wanted to touch on fairness. It's a really vague term, but I think in the context of GRIN, there are a couple of things that I wanted to touch upon. And there's the concept of fair lunch, the emission rate, proof of work, and governance. Those are the four things I wanted to discuss. Fair lunch. So there is this concept fair lunch. So the project was announced back in 2016, really. So it's a 3 years old project already. It's open source, 100% community driven. It's solely founded by donations. And it was launched earlier this year, at the start of this year. There was no ICO, there's no founder's reward, there's no pre-mine, no airdrop, no nothing. There are some people who are saying that, there were some VC-founded startups that they were able to put millions into mining GRIN at the launch of GRIN. So they are saying that the launch wasn't really fair. But in my books, this is as fair as you can get today. We live in a world of capitalism, so whoever has the money can do whatever they like, really. But this is as fair as you can get today with launching a cryptocurrency. The emission rate is another thing that there is a misconception about it. Some people don't really understand it at first. And I also, when I first came up across the 1 GRIN per second forever, I was also a bit confused. But really, if you spend some time thinking about it, it's not as bad as it sounds. It's actually really very minimal. And I really like the design of 1 GRIN per second. There's no advantage to early adopters, as it is with other cryptocurrencies who have maxed capacity, max supply, fixed supplies. And really, the inflation goes down linearly. So really, in 10, 20 years, you have inflation that is akin to gold inflation. It's really close to gold. It's much closer to gold than Bitcoin, for example. Bitcoin is even harder. Proof of work, there is Kuko cycle used for proof of work. I added this in the fairness category because I think it's worth discussing. There was this, ASIC aversion in the cryptocurrency community in general. If you look around, and this was also initially true for GRIN, But eventually ASICs are unavoidable. And in GRIN, we figured this out pretty relatively quickly. And the way that the proof of work algorithm was designed is there are two proof of work algorithms really used from the Kuko cycle family. One is ASIC friendly, which is it started with 10% of the rewards going to that algorithm, people who are mining in that algorithm, and 90% ASIC resistant. The ASIC resistant algorithm is phased out, will be phased out in 2 years, and there's only going to be the ASIC friendly algorithm used as a proof of work. Um, the the reason for that is, that the developers of GRIN believe that, ASICs are unavoidable, and they try to promote open hardware design and getting an ASIC that is openly designed. But it's really hard, really, to get open ASIC development. But it's at least it's encouraged. On the governance side, there is no foundation. There is a so-called technocratic council that it was bootstrapped initially. Part of it were mostly core developers. And the reason for the existence of the council was to manage the donation fund, where funds end up being utilized. And the council, it's still a centralization point in the project, and the people who are running the council are aware of it. So there is a move towards sub-teams. So each component in GRIN will get eventually its own subteam. You have a node subteam, you have a wallet subteam, you have a fundraising subteam, community subteam. There are lots of different subteams that are popping up. And then there's also an RFC process that has been put in place during the past months. There are a bunch of things, changes that improvements in the protocol, and obviously you have to have a process to get those to get consensus on those changes. And there are also the public bi-weekly development and governance meetings. They are open to anybody to join. As I said earlier, I'm not a developer, but I was attending those meetings. Unfortunately, lately, not so much because of work and stuff, but I used to go attend those meetings. They're pretty fun to watch the thought process of the team, how they work. So yeah, I think that's pretty much it. There are a couple of things that you can do if you are interested in the project. There are lots of research going on with lots of new interesting technologies, and every other week we have there are academic papers, research is going out, and for example, we had the Halo paper come out a couple of weeks, which is a big improvement really for blockchains, and there are open positions. There are no positions. I mean, if you have an interest and you find something interesting here, you can just jump in the project and help out. As I said earlier, the project is founded solely by donations. And yeah, don't ask for permission. It's open source. I hope you are familiar with open source and how it works. So yeah, I think that's pretty much it. If you have any questions. You have a microphone?
Thank you for your presentation. My question is, how do you guarantee privacy when you have to force to open a direct connection to the one you are making a transaction to?
Yeah, that's a good point. I didn't really mention this. This is one of the ways you can build transactions, but it's not the only way. You are talking about the HTTP, because right now the wallet supports sending transactions, building transactions via HTTP, and this is actually a good point. It's a privacy concern because you have to expose your IP, but it's not the only way you can build your transactions. You can also just send an email, and there's also discussion for doing this transaction building via Tor and I2P. So yeah, it's a work in progress, but HTTP is not the only way. And actually, there's some people in the core development team, they are pretty eager to get rid of that choice, really.
So
Okay.
So regarding privacy, like you talked about aggregation of transactions.
Yep.
As far as I understand, it happens in regular nodes or only minor nodes. And in case that
In all nodes.
yeah, real just normal nodes, yeah.
Yeah.
So what happens if like a lot of nodes are owned by analysis companies, or they just broadcast the transaction instead of aggregating, and then, well, the transaction is public. I know the amounts are invisible, but you can then still like see the link between outputs.
Absolutely, yeah. So you need, I mean, with any kind of network, you need to have a majority of honest nodes. Obviously, if you have, if the majority of nodes are dishonest, they will be able to de-anonymize the network, the whole network. And the same stands for example, 51% attacks, right? So if the majority are dishonest, they can just kill the coin. You don't know that the attack has happened. Yeah, yeah, that's true. That's a good point. But eventually you will get to know because this will have repercussions. I mean, if your privacy is breached, eventually you will get to know about it. So I'm not really concerned that you will not get to know about this. And yeah, it's an issue, but this is really an issue with any kind of network. I mean, obviously with 100 with zero knowledge or like Zcash, you are probably are not able to do this kind of attack. But you know, in that case, you have other issues. Like for example, you have more complex code, and it's much easier to have bugs, right? And you have bugs also. I think recently there was a bug where you would be able to expose the IP of the sender. So you know, there are some trade-offs. But yeah, good point.
There is another well-known trade-off between the privacy and safety, meaning that if you have a complete private system, it's very hard to prove that there is no additional emission due to some bug or mistake.
Sure.
And it's more theoretical problem than Mimble-Wimble problem itself. But basically, maybe you have some plans on proposing some formal verification system so that can prove that there is actually no emission due to a bug happening.
So at the moment, I think so. At the moment, there is when you download the chain, if there is no bug, you can still prove that there's no inflation. But if there's a bug, yeah, you cannot really prove that there is no inflation. I think this is a concern with all kinds of privacy-related currencies. I'm not aware of really of how you can avoid inflation if there's a bug that breaks, for example. At least, yeah. So it's really hard because if those coins are never moved, or you know, usually you don't have all the coins moved. It's really hard. I'm not aware of any technique to avoid that.
So thanks for very interesting talk. I don't understand very well the linkability. You said that it's similar to Monero, but in Monero you don't know which output is spent and which not. And here you know which is spent because you are pruning it. So how it works?
So pruning, when you prune on chain. And on chain, you only see all of the transactions are aggregated, and you know that these outputs are spent, so you can prune them after a while. But the issue with linkability is off-chain. So as a node, when you receive a transaction, and this transaction is not aggregated, you know that these are its inputs and these are its outputs. I'm not sure how exactly it works, how this issue is off-chain for Monero, but off-chain for GRIN is an issue. And I think it's probably an issue for Monero.
And if I would have a malicious node which would store all transactions, not waiting until it will be in blockchain, I could link everything?
Yeah, assuming all of the transactions that your node has, you receive them unaggregated. Yeah.
Thanks.
Any other questions?
On this point as well, you compared it to the security model of Bitcoin, where at least 51% have to be honest. But in Bitcoin, it has to be 51% of the miners, which have a strong economic incentive. But did I understand it right that here a regular normal node with no real financial stake has to be honest as well? Like I can easily spin up 1,000,000 nodes on Amazon
Yep.
for this attack.
Yeah, sure. You can do that. And you know there are some, for example, that the Lion helps in that case. You know, it tries to hide that transaction. So you maybe your 1,000,000 nodes, you spin up 1,000,000 nodes, but then you have to force everybody else to connect to your nodes. For example, then the Lion works in the case you stem a transaction to a node that you have connected to. And that's one case. And then it's similar to the previous question, like all of these 1,000,000 nodes have to be able to get all of the transactions unaggregated. So then you can link all of the inputs and the outputs.
Which I could do if I spin up 99% of all nodes by myself.
Yeah, theoretically, yeah, you could do that.
No other questions?
Right, thank you
If not,
everybody for
so
joining.
thank you, Michalis.
Thank you.